Hi everyone. We're going to locate the absolute extremum of the function on the closed interval, and we're going to evaluate -2 as your left endpoint and 2 as your right endpoint. The first thing I'm going to do is find the critical values first by taking the derivative, and we're going to use the quotient rule by multiplying your denominator by the derivative of the numerator minus your numerator times the derivative of your denominator. And then you take your denominator and you square it. You clean this up, you get 2x squared plus 2 minus 4x squared. And, this should be squared all over x squared plus 1 squared. When I clean this up, I get negative 2x squared plus 2 over x squared plus 1. I prefer to write this as 2 minus 2x squared over x squared plus 1 squared. Keep forgetting to square it. Okay, so we set this to 0 to find your critical numbers, and what happens is the denominator cancels. So we're going to get 2, as you saw for the numerator, 2 equals 2x squared. So x squared equals 1, so x equals plus or minus square root of 1, which is just 1. And both plus and minus 1 are in our closed interval here. So we're going to evaluate these numbers. For the critical numbers, we're going to evaluate f of -1 and f of 1. And for our left endpoint, we're evaluating f of -2. And for our right endpoint, we're evaluating f of 1. So when I evaluate for -1, remember this is our function. Now for -1, I'm going to get -4/5. When I plug in -1, I get a -1. And when I plug in 1, I get 1. When I plug in -2, I get -4/5. And when I plug in 2, I get 4/5. So our minimum is my smallest number, which is here. My largest number is 1. This is at your critical number. So that's your maximum. So your min and max occurs at your critical numbers, not at your left and right endpoints. This should have been an X. I knew something was off. Okay, so there's your function. So anyway, there's your min and max. They do not happen at your left and right endpoints. Thank you. Have a nice day. Bye-bye.